Sleep. It's something every complex animal does. For us humans, it takes up about a third of our entire lives. I mean, think about that. That's literally decades spent in this weird state of suspended animation. And for something so common, it's also one of biology's biggest puzzles, right? It makes us totally vulnerable, it takes up a ton of time, and yet we absolutely cannot live without it. So what is really going on when we close our eyes every night?
It all kicks off with a question that, on the surface, seems pretty simple. Are there any animals out there that just don't need to sleep? It sounds like a straightforward biology question, but the answer? Well, it pulls back the curtain on this incredible world of evolutionary strategy and one of life's deepest mysteries.
So the quick and easy answer? It's a no. As far as we know, we haven't found a single complex animal that can just skip sleeping altogether. But that's where the simplicity ends, because sleep isn't just one thing. It's this whole spectrum of different behaviors, and each one is perfectly tailored by evolution to solve a very specific problem for survival.
And to really see what I'm talking about, we've got to take a look out into the wild, because the strategies that nature has come up with for getting some rest are, frankly, astounding. They span a range that is just truly mind-boggling.
I mean, just look at this. It's wild. On one end of the scale, you've got these huge animals like elephants and giraffes that are somehow getting by on just 2 or 3 hours of sleep a day. But then, on the other extreme, you have a koala that can be out for, get this, up to 22 hours. That's a 20-hour difference in daily downtime. So what's the deal? Why such a huge variation?
Well, it all really boils down to one thing: survival. For a koala, life is a non-stop game of conserving energy. Its diet of eucalyptus leaves is super low in nutrients, so for them, sleep isn't a luxury, it's a critical survival strategy. But for a giraffe, a massive prey animal out on the open savanna, being totally unconscious for hours on end is basically a death sentence. For them, survival means staying as alert as possible. Sleep is custom-built for the job.
But what if you can't afford to stop moving? Or what if you have to keep watch, even for a second? Well, nature, as always, came up with this genius workaround: unihemispheric sleep. It's basically the biological equivalent of sleeping with one eye open. It lets one half of the brain go offline and rest while the other half stays totally on duty. And who uses this superpower? You see it in animals like dolphins and whales. They have to keep swimming to come up for air, right? So if they fully shut down, they drown. This is absolutely crucial for them. Some birds even use it to stay on the lookout for predators or to navigate during those long migratory flights. It is the ultimate form of biological multitasking.
So, okay, we've seen how wildly different sleep can look from one animal to the next, and that brings us to the really fundamental question: why? Why is it so essential for everyone? It turns out, calling it rest doesn't even begin to cover it. Sleep isn't a break for your brain. It's when the night shift clocks in for some serious work.
This quote here from Johns Hopkins Medicine just nails the modern view on this. For the longest time, we kind of thought of sleep as just powering down, a passive state. But nope. We now know the brain is absolutely buzzing with activity, and it's performing tasks that are critical for our survival and our health.
So, what's actually on this nightly to-do list for the brain? Well, first up, it's conserving and storing up energy for the day ahead. Second, it's giving the body time to repair tissues and boost the immune system. And third, and this is maybe the most important job of all, it's performing critical maintenance on the brain itself.
Probably the best way to think about this brain maintenance is to picture a library. All day long, new books. That's your memories, your experiences, everything you learned. They're just piling up all over the place. Then, at night, the librarian, your brain, comes in and starts to tidy up. It sorts through everything. It shelves the important memories, it throws out the junk, and it organizes it all so you can actually find what you need the next day.
And the amount of time we sink into this process is just staggering. We're talking about roughly 1/3 of our entire lives. Think about that for a second. If you live to be 90 years old, that's 30 years spent completely asleep running this essential maintenance program night after night after night.
So what does this nightly maintenance job actually look like for us humans? It's not just one long, deep sleep. Oh no. It's more like a journey our brain takes, cycling through this really complex and predictable pattern of stages. And each one has a very specific job to do.
Okay, so here's the path your brain follows. You start by just drifting off in stage 1. Then you go a little deeper into stage 2, which is a lighter sleep where a lot of that memory sorting happens. From there, it's down into stage 3, that super deep, restorative sleep that's so important for physical repair. And finally, you pop back up into REM sleep, where your brain activity goes wild and you have those vivid dreams.
And if you look at how we spend our time, it's pretty interesting. Almost half the night is spent in that light sleep of stage 2. That's prime time for all that memory sorting we talked about. And then the deep, physically restorative sleep and the active dreaming of REM sleep each get about a quarter of the night's budget.
And here's the kicker. This isn't a one-and-done trip. Your brain completes this entire 4-stage cycle in about 90 to 120 minutes. And then it does it again, and again, and again, about 4 or 5 times every single night.
But, and this is a big but, even with everything we've learned about the stages and the functions of sleep, scientists are still scratching their heads about some really enormous questions. We found a lot of the pieces to the puzzle, but the full picture is still surprisingly, well, blurry.
And this is where you really see the gap in what we know. For instance, we know for a fact that sleep is essential for survival, but we have no idea why evolution couldn't come up with a safer, more efficient alternative. We know that not getting enough sleep is incredibly damaging, but we still don't really get the true purpose of our dreams.
You know, this quote from the Cleveland Clinic really sums it all up perfectly. Our understanding is like a half-finished jigsaw puzzle. We've got the corners and some of the edge pieces figured out. We can see parts of the image forming, but there are these huge gaping holes right in the middle. We're getting a handle on the what, but that big why is still kind of out there.
So we spend a third of our lives doing this essential biological reboot, every single night. And that leaves us with a final, really powerful question to think about. What would change for all of us, for our health, for our technology, even our understanding of consciousness itself, if we finally cracked the code? If we finally solved the great sleep paradox and truly understood why?